In this video, we will discuss graphing systems of linear equations. In order to graph systems of linear equations, we must first create function tables in order to get points. So in our first example here, we can select an x value of 0. That would force our y value to be 2. We could also select a y value of 0, which would force our x value to be 2. Notice that this particular equation is in the standard form of a line. When that happens and we are using Get More Math, it is important to graph both of the intercepts. So let x be 0, let y be 0. Our second equation is in the same format, so we have if x is 0, y must be 2. If y is 0, x must be negative 2 in order to get that positive 2 back. We can now graph our line. Our first line will have points at 0, 0, 2, and at 2, 0. Our second graph will have points at 0, 2, and negative 2, 0. Note that these graphs do intersect. The system's solution is the point where these lines intersect. So in this case, the solution to the system is 0, 2. Now we can use graphing in order to solve our next system, and this is x equals negative 5 and x equals 0. Note that no matter what we do here, our x value has to be negative 5. Our y value could be anything, but x has to be negative 5. This is going to be a vertical line through that value x equals negative 5. Similarly, we could have the point 0, 0 and 0, 5, as long as our x value is 0. Both of these are vertical lines, so we're going x equals negative 5 and x equals 0. Remember before in our last problem, we had that the solution to our system was the point where these lines intersected. However, these lines don't intersect. Therefore, the system's solution, we're going to select parallel. That is equivalent to saying that there is no solution for that graph. In this example, we will look at y equals 4x plus 5 and y equals x plus 2. Both of these equations are in slope-intercept form. In that case, we should always choose x equals 0 to use that intercept, which here would be 5 for our first equation. We can then test a value such as 1. 4 times 1 is 4, plus 5 is 9. So we can check those points. Again, we will choose x equals 0, forcing our y value to be 2, and then we can choose something like x equals 2, and our y value will then be 4. Here it's saying 2 is too big to use, so we'll switch to 1. And make that 3. And Get More Math seems to like that point better. We can now use the graphing tool in order to graph these points or these lines. So we'll start with the point 0, 5, and then 1, 9. And then we go from 0, 2, and 1, 3. And we can check that as well. Again, when our lines do intersect, our solution is that point of intersection, which here is negative 1, 1. So the solution to our system is negative 1, 1. We've answered a few of these correctly, and now it's going to take away those tables and let us go straight to graphing. In order to do this, we can simply graph our first equation using the methods that we did for slope-intercept. So we can start at our y-intercept, which is 3. Notice that our slope is 1/2, so that's up 1 over 2. The next point would be here. If we let x be 0, for our second equation, negative x plus y equals 5, then y has to be 5. If we allow y to be 0, x must be negative 5. We can graph those. And again, notice that our solution to this system is the point of intersection, which in this case is negative 4, 1. And in our next example, again, our lines here can be graphed without those tables. So first we have y equals negative 1. Note that this is a horizontal line through the y value negative 1. We can then graph the second equation, which is y equals negative 1/2 x minus 1. Our y-intercept is negative 1. Our slope is negative 1/2. So we'll go down 1 over 2. And then we can check this. Our intersection point here is 0, negative 1. And we could continue to graph in this manner. So at this point, I would like you to log into your own Get More Math account and work through the assignment that is preloaded in there for you.